The next program is going to bring together two of my great enthusiasms for life, Quiz Bowl and humiliating soulless machines. This has been labeled the HSNCT exhibition match. That's not true. This is a blood match, or electrons, I guess, current. But what we have is going to be the third match between the representatives of humanity in the form of 4 of our best moderators from this tournament against the QANTA program that's been developed by Professor Jordan Boyd-Graber of the University of Colorado Boulder. The first match 2 years ago ended in a draw, which was not so great for humans, but fantastic for the cliffhanger. We came back next year. Humans walloped the computer. I'm fully expecting that to happen again. Go humanity. But before we get into that, I'd like to turn this over to Dr. Boyd-Graber, who will give a brief explanation of the technology involved, and if you're particularly interested in this, how you can get involved and develop and play against QANTA on your own. So, here we go.
All right, thank you very much. Happy to be here. What we're going to see in a little bit is a computer that can play Quiz Bowl, and it will be facing off against Quiz Bowlers, as R said. Our system is called QANTA. QANTA used to stand for something else, but now it stands for Question Answering is Not a Trivial Activity. And before we get to the match, I'm going to talk a little bit about who we are, why playing Quiz Bowl on a computer is at all interesting from a scientific perspective, since I'm a professor of computer science. And then I'll talk about what's going to happen in the match and give a little bit more background. So I'm Jordan. I used to be a Quiz Bowl player at Caltech and Princeton. A lot of the work on the system was done by Mohit Iyer, whom you may have seen at previous HSNCTs running QANTA. So he was a champion at TJ about a decade ago at HSNCT. Next month, he'll start work at the Allen Institute for Artificial Intelligence. And he's also becoming Dr. Mohit Iyer next week, which is why he's not here today. Next year, he'll be a professor at the University of Massachusetts Amherst. So if you're interested in working on this kind of thing, come work with me, or go work with Mohit at UMass Amherst. Taking over the reins are 2 new students, Pedro Rodriguez, who you'll see in a little bit, helping run the demonstration, and Shifeng, who is a first-year PhD student at Maryland. And then there's a whole cast of supporting characters that you can look at on our webpage. Yes, and all approachable, as I'll talk about in a second. So one thing that I often get asked is didn't IBM do this already? And so the answer is no. So Jeopardy is an inferior trivia competition. The reason is that it's on TV, and so if you could interrupt questions, it would make for bad TV. But the structure of Quiz Bowl questions is pyramidal. That allows you to better differentiate who is a better player, more knowledgeable, and that makes it a more interesting computer science problem as well. Another differentiation is that we are not IBM or Google, and we don't mind embarrassing ourselves. So we lost last year, and that's fine. This is a learning experience for all of us. And also, unlike IBM and Google, all of our code is online. You can run it, you can play around with it, you can see exactly what we're doing, and hopefully learn from it. Okay, so why is Quiz Bowl interesting? So here's a question. Anyone know the answer to this question? Yeah, die Zauberflöte, or the magic flute. So why is this interesting? So let's take a look at some of the things. Some of the things happening in this question. So you have references to things that are never named, and so the question mentions the librettist of the opera, but never names Emanuele Seconda, nor does it mention a character, Papageno. And then there are more complicated things going on, like references to Tamino across multiple questions. And a good player or a computer needs to figure out what is the reference between these entities. And then finally, Quiz Bowl sometimes involves inferences at the semantic level. You need to know what words mean in order to answer questions. So an enchanted woodwind instrument, at the end of the question, if you haven't gotten it off of earlier clues, you could use your knowledge of what words mean to figure out what the answer is. And if computers could do that, that really advances the state of the art. Okay, so how do we approach this problem? We approach it in two phases. The first is to figure out what the answer is, to take a guess. We call that our guesser. And the second phase is to buzz in, to decide when to hit the buzzer and give your answer. So I'll first talk about how to guess. And so the way that we do this is we have a lot of data from past Quiz Bowl questions and Wikipedia. We load that into a vector space. And then questions come in, and we need to match up our database to the questions that come in. And so as a question comes in, we put it into this vector space. And things that are close together are similar questions. And things that are not like each other are further away. And so when a question comes in, we embed it into this vector space, and we see what's close. And then we look at all the things that are close, and those become our guesses. The other phase is deciding when to buzz in. And so how do we know when a buzz is a good buzz? So in 2011, we built a little web app, and we collected data for 2 weeks. And it was very popular, so popular that folks went off and bootlegged this program that became Proto Bowl. And later, we collaborated with the people who bootlegged our software, and they're now co-authors on our papers, and we train our system on Proto Bowl data. And so there are a lot of people playing on Proto Bowl, probably many people in this room. And we're trying to beat the very best Proto Bowl players, so we're aiming to beat the top 1% of people on Proto Bowl. And we're doing fairly well at that, but we shall see truly how well we are doing. And so we're using deep reinforcement learning to do this. And this allows you to vary your strategy based against the kind of player you're playing against. And so it builds predictions about when it thinks you will buzz, and then it times its buzz appropriately. So it tries to buzz just before you would, after building a model of how you buzz. But we don't know whom we're playing against, so we're playing against a generic top Proto Bowl player for this match tonight. But in general, we have a paper last year from International Conference of Machine Learning where we optimize against specific players. Okay, so when we plug in our system, you will see all of the guesses that the system is generating. And the two columns there are showing the strength of the guesses, so higher numbers are better. And then in the top left, there is a number. When that gets above 0.5, it will buzz in. And so as it's getting higher and higher, closer to 0.5, it will decide to buzz in then. You will also see how much of the question has been revealed to the computer. So Pedro will be pushing a button every time the moderator says a word. That feeds a new word into the system. And you can see which words the system has gotten by looking on the screen. And then we also display the score. All right, so that's what's going to happen in a second. But it isn't all fun and games. This also has real-world applications beyond trivia. And so Quiz Bowl is a lot like the problem of simultaneous interpretation, where you have a stream of words coming at you in German or Japanese, and you need to translate them into English. And German and Japanese have verbs at the end of the sentence. And so guessing what the verb is going to be in German or Japanese is a lot like playing Quiz Bowl. You have words coming at you, and you need to decide when you know what the verb is, then you buzz in and you translate the sentence. And so we use the same technology to build better simultaneous interpretation systems. All right, so let's review the history thus far a little bit more. So we played against 4 very strong challengers 2 years ago, and it ended in a 200-200 tie. And our system shut down after playing 40 questions. And so we were unable to do a tiebreaker. And so that built suspense for the following year. In between, we played against Ken Jennings and beat Ken Jennings. Thank you. But people responded, well, Ken Jennings is a nice guy and all, but he's not the best Quiz Bowl player. So we faced a really formidable team last year, and they crushed us. We had some late season injuries and things like that, and so plenty of excuses on our system. I believe that they're resolved. We shall see. The machine learning community also competed on this, so we held a competition. People around the world could build quiz bowl systems. A team from Japan won that, and we faced them off against California's NAQT team. The humans still won, but by a narrow margin. There were lots of negs everywhere if you saw the match. The link is available on my webpage. But to the main event, we'll do 40 toss-ups. You've heard them earlier today in rounds today. The players were sequestered, so they did not hear them. No bonuses and off the clock, because we'll probably have crosstalk and things like that. Afterwards, I'll do a Q&A session if people want to stay for that. If you want to skedaddle and get to bed, that's fine too. Please leave quickly, and if you want to stay for the Q&A, move on up to the front, and we'll have a lively Q&A session with me and Pedro. All right, so without further ado, I'll turn it over to our MC.